Hello everyone, welcome back for part 4 now of the 4.3 notes, where this will be the last part that we're going to take a look at for the logarithmic equations. Logarithmic functions, I should say. We're dealing with both, but we're going to graph them this time. Now, graphing the logs, it's kind of like graphing the exponential functions. There's not much really to do about it other than trying to just plug in some points. We will have actually a vertical asymptote always for logs, because it's not possible to take a log of 0. It's also not allowed to take a log of a negative number. So there will be this kind of a standard vertical asymptote at x equals 0. The y-axis. It will be our asymptote, and then we will not have any other asymptotes to deal with. And we can proceed with graphing this one just by picking some points. There are some normal points that you could pick, some pretty standard ones, but you have to understand that we're dealing here with things that have to do with powers of 3. Those are the x values that we would like to plug in, are various powers of 3, and that will get us what we need. We have here, and when I say what we need, I mean if we want to get some decent y values where we're getting whole numbers is what I mean by decent values, where we're getting basically whole number answers that are easy to plot on here. Then that's what we would want to do, is we would want to plug in for x various powers of 3, like 3 to negative something power, also 3 to the 0 power, also 3 to positive powers. Those are the kinds of x values that we could pick. There's a little tip given over here, which is that we can rewrite this equation into the exponential form. And if you remember the loop-de-loop here, the way we have it, it's kind of backwards, so our loop-de will go this way. This goes like 3 to the y power equals x. And so we can choose some different y values. Like what about, for example, if we want y values that go like -2, -1, 0, 1, 2, stuff like this. Those are the y values that we're picking, and it's kind of weird we're picking ahead of time the y values. But of course, this is an inverse for exponential. And so if a point is on an exponential graph, then the point, for example, if xy is on the graph of 3 to the x, then the point, if we have f inverse of x, it will have the point, and this one should be log base 3 of x, by the way. That would be the inverse. It should have the point yx on there. It just, see, it switches the x and the y. So it kind of makes sense to pick the y's first, because we understand how to do 3 raised to different powers better than we understand how to take log base 3 of different numbers. And so I hope that that makes sense. But we will pick here which y values we want to get. And then we'll say, okay, so 3 to the -2 power, because this is our y value, is 3 to -2 power equals our x value. And so this should go like 1 over 3 squared, which is 1/9. That will be the x value. When the x value is 1/9, the y value is -2. So that's the point there, goes 1/9 and -2. Similarly, 3 to the -1 power is 1/3, 3 to the 0 power is 1, 3 to the first power is 3, and then 3 squared is 9. So we would have, for example, the point over here, which is 9, 2. That point will be on there. And so we can plot those points, and then we can just get the general shape going like this, and we can graph it just like that. And then speaking of these kinds of graphs, we will have the same sort of transformations for logs as we had for any other functions before. We're able to adorn this log function with all kinds of little accoutrements. We can have the coefficient in the front, which this one can reflect it across the x-axis. It also will do this kind of vertical stretching and so forth. We can shift to the right by h by doing this little one. It would be possible as well to do any kind of, reflecting across the y-axis that we want to do by putting either a negative in front of x, or whatever the case may be. I'm actually going to modify this one a little bit, add a few more of the transformations that are possible. We can go log base b, and then inside of here, we can put either a positive or negative, and I want to put that for a, just because this is how we formatted it previously, so I want it to be the same. We can put plus or minus, and then we can actually have a coefficient here that's going to do this horizontal shrinking or stretching. Then we can shift to the right by h, and now we can shift up by k. And so I just wanted to add this little bit of extra stuff to make it more inclusive. And so now we have all of the transformations that are possible to do with log. And so think about what's going on with this one. It's the log base 2, and then it goes, this one here, it is more recognizable if we change that to x plus 1 instead of 1 plus x, so it should be to the left by 1. So actually we will have vertical asymptote at -1, and I'm crossing the asymptote there, shouldn't be doing it. Okay, and so we have vertical asymptote there, and then we would just plot some points. We have it shifted up by 2, but it's not so clear how to make an upward shift by 2 for the log, because there are no horizontal asymptotes or any vertex or anything like that to give us kind of an orientation. So the shift up by 2, it ends up basically affecting where this x-intercept is. But either way, we're going to end up just having to plug in points. Now, it's a little bit tricky to try to turn this one into an exponential form. We know, though, that we're trying to obtain some powers of 2 in this argument here. We want 1 plus x to be powers of 2. And so what if we did, for example, we plug in this value maybe of -1/2? Then it's going to be going log base 2 of 1 minus 1/2, which is log base 2 of 1/2, and this thing goes 2 to the -1 power, so this is going to be -1. And then all the time it has plus 2 on the end of it, so I want to go plus 2, so it's going to go -1 plus 2, which is 1. So at -1/2, which is here, we should have a y value of 1, so we would put that point on there, for example. We could have also, you know, if x is 0, that's a really nice one, because then it goes log base 2 of 1, which log base 2 of 1 is just 0, of course, and then we would go plus 2. And so we would get 2 for this one. I mean that this one was 1 as well. And then we could plot another point. Maybe it could be useful just to plot 3 points, because once you have the 3 points, you can just stick that general shape on there, and everything's going to be good. And so another point that we can have, what about just 1? Because then it will go log base 2 of 1 plus 1, which is log base 2 of 2, and that's equal to 1. And so it will go 1 plus 2, because here we just got 1 from this part, so then plus 2 it will give us 3. Because always, I was forgetting the plus 2 that's on there. Plus 2, so plus 2, and it will give us 3. So we have that one. And now we can come here and talk about the domain and range momentarily for the logs, because the domain and range, they're very simple. They are just the polar opposite. They're the reverse of what we have for the exponential one. And what I mean by reverse is that you just take the domain for the exponential case and you put that as the range for the log case. And you take the range from exponential, you put that as the domain for the log. You just switch them. And so log, it will always have a range that goes -infinity to infinity, because of course if you graph it, it's always coming from -infinity. You will have a vertical asymptote. It's coming from -infinity and it's just going towards infinity like that. And then the domain, it will start whenever you're checking the domain. You want this argument, whatever is here, this argument, it always has to be greater than 0. So for example, with number 30, we could check, you know, the range is just going to be -infinity to infinity. We don't have to think too much about that one. But for the domain, to find it, we need this argument over here, the one that goes x plus 3. We need it to be greater than 0. And so that means that x should be greater than -3. So that will be the domain. It goes from -3 up to infinity like this one. And so that's how we will be able to do it. I hope that this video was helpful for you all. We will pick up with some more things having to do with actual equations now, logarithmic and exponential kinds of equations, solving those for x. That's going to be a lot of fun. And then we'll get into some applications as well. So I hope this video was helpful for you guys, and I will catch you in the section 4.41. So thanks for watching.